In the previous video, I showed you how to upload a CSV using Spring Boot. But what if you need to deal with large file that requires extensive data processing? That's where batch processing comes into play. Batch processing is a method that allows us to efficiently process large volumes of data in chunks without the need for constant user interaction. It's a game changer when it comes to handling tasks like data cleansing, transformation, and loading. But why does it matter? Imagine having a massive data set that need to be imported, processed, and transformed. A traditional approach might struggle, leading to slow performance and potential system issues. That's where Spring Batch steps in. Spring Batch is a powerful framework built on top of the familiar Spring Boot, designed specifically for batch processing. It provides a structured and efficient way to handle large-scale data processing tasks. With Spring Batch, you can process data in chunks, manage jobs executions, handle errors gracefully, and even restart failed jobs seamlessly. It's a robust solution for those scenarios where uploading large files requires more than just a simple file upload. In the upcoming video series, we'll dive deep into Spring Batch. I'll walk you through the concepts, the code, and real-world examples, and absolutely I will show you how you can optimize your batch processing to reduce the execution time. If you're ready to level up your Spring Boot skills and tackle large-scale data processing, hit the subscribe button and let's embark on this journey together. I would like also to invite you to visit my website and also connect with me on social media. I will leave you all the links below in the description of this video. So let's connect. Now, with no further ado, let's get started. First, let's check this introduction about Spring Batch. So many applications within the enterprise domain require bulk processing to perform business operations in mission-critical environments. So these businesses' operation include: first, we have automated complex processing of large volumes of information that is most efficiently processed without user interaction. So these operations typically include time-based events such as month-end calculations, notice, or correspondence. Then, periodic application of complex business rules processed repetitively across very large data sets. For example, insurance benefit determination or rate adjustments. And finally, integration of information that is received from internal and external systems that typically requires formatting, validation, and processing in a transactional manner into the system of record. So batch processing is used to process billions of transactions every day for enterprises. Now let's see what is Spring Batch. So Spring Batch is a lightweight, comprehensive batch framework designed to enable the development of robust batch applications that are vital to the daily operations of enterprise systems. Spring Batch builds upon the characteristics of the Spring framework that people have come to expect: productivity, Pojo-based development approach, and general ease of use, while making it easy for developers to access and use more advanced enterprise services when necessary. Spring Batch is not a scheduling framework. There are many good enterprise schedulers such as Quartz, Tivoli, Control-M, and others, available in both the commercial and open source spaces. So Spring Batch is intended to work in conjunction with a scheduler rather than replacing the scheduler itself. Spring Batch provides reusable functions that are essential in processing large volumes of records, including logging and tracing, transaction management, job processing statistics, job restart, skip, and resource management. It also provides more advanced technical services and features that enable externally high volume and high performance batch jobs through optimization and partitioning techniques. You can use Spring Batch in both simple use cases such as reading a file into a database or running stored procedures, and complex high-volume use cases such as moving high volumes of data between databases, transforming it, and so forth. High-volume batch jobs use the framework in a highly scalable manner to process significant volumes of information. So what is the background of Spring Batch? So while open source software projects and associated communities have focused greater attention on web-based and microservices-based architecture framework, there has been a notable lack of focus on reusable architecture frameworks to accommodate Java-based batch processing needs, despite continued needs to handle such processing with enterprise IT environments. So the lack of a standard reusable batch architecture has resulted in the proliferation of many one-off in-house solutions developed within client enterprise IT functions. So Spring Source, which is now VMware, and Accenture collaborated to change this. Accenture's hands-on industry and technical expertise in implementing batch architecture, Spring Source depth of technical experience, and Spring proven programming model together made a natural and powerful partnership to create high-quality market-relevant software aimed at filling an important gap in enterprise Java. Both companies, they worked with a number of clients who were solving similar problems by developing Spring-based batch architecture solutions. So this input provided some useful additional detail and real-life constraints that help to ensure the solution can be applied to the real-world problems posed by clients. Accenture contributed previously proprietary batch processing architecture frameworks to the Spring Batch project, along with committed resource to drive support enhancement and the existing feature set. So Accenture contribution was based upon decades of experience in building batch architectures with the last several generations of platforms such as COBOL on mainframes, C++ on Unix, and now Java Anywhere. So the collaborative effort between Accenture and Spring Source aimed to promote the standardization of software processing approach, frameworks, and tools enterprise users can consistently use when creating batch applications. Companies and government agencies desiring to deliver standard proven solution to their enterprise IT environment can benefit from Spring Batch. The following diagram is a simplified version of the batch reference architecture that has been used for decades. So it provides an overview of the components that make up the domain language of batch processing. So this architecture framework is a blueprint that has been proven through decades of implementation on the last several generations of platforms. So Spring Batch provides a physical implementation of the layers, component, and technical services commonly found in the robust, maintainable systems that are used to address the creation of simple to complex batch applications with the infrastructure and the extensions to address very complex processing needs. Now let's break down each component and each part of this diagram and explain them separately. So in batch processing, we have several components. First, let's start with the JobLauncher. So the JobLauncher is simply an interface for launching a job with a given set of job parameters. So we will see later on what are job parameters and how we can pass them. And then each JobLauncher will launch a job. The job, it's a section that I will explain in just few moments in details. And then each job might have or can have one or several steps. So here we can see step 1 and step N. And each step is composed of 3 main elements. So the first thing is an item reader. So the item reader is an abstraction that represents the retrieval of input for a step and one item at a time. So when the item reader has exhausted the items it can provide, it indicates this by returning null. So when the item reader returns null, means that we no longer have records or data to read. So you can define more details about the item reader interface and its various implementation in the readers and the writers. So the item reader is able to read data from, for example, a database, a file, and so on and so forth, any storage system you want. And then once we read an item, we pass it to the item processor. So the item processor is an abstraction that represents the business processing of an item. So while the item reader reads one item and the item writer writes one item, the item processor provides an access point to transform or apply other business processing. If, while processing the item, it is determined that the item is not valid, returning null, indicating that the item should not be written out. You can find out more details about the item processor in the interface in readers and writers. And then finally, we have the item writer. So the item writer is an abstraction that represents the output of a step. So one batch or chunk of items at a time. Generally, an item writer has no knowledge of the input it should receive next and knows only the item that was passed it in its current invocation. You can find more details about the item writer interface and its various implementation in the readers and the writers as well. And all these three parts, JobLauncher, job, and the steps, they use and they communicate to the job repository. So the job repository is the persistence mechanism for all of the stereotypes mentioned earlier. It provides CRUD operations for JobLauncher, job, and step implementations. When a job is first launched, a job execution is obtained from the repository. Also, during the course of execution, step execution and job execution implementations are persisted by passing them to the job repository or to this repository. When using Java configuration, the annotation enabled batch processing annotation provides the job repository as one of the components that is automatically configured. So this is the global overview of the batch architecture. Now let's move on and break down and see how the job works. Now let's break down the job. So a job is simply a central entity that encompasses an entire batch process. So configured through XML or Java-based step, referred to as job configuration. It acts as the top level element in a hierarchy, organizing multiple step instances logically. These steps are grouped within the job to form a cohesive flow, allowing for global configuration of properties, such as restartability. The job configuration includes the job's name, the definition and ordering of its step instances, and as specification of whether the job restarts or not. Then within a job, we have a job instance. A job instance in Spring Batch represents a distinct run of a batch job. For example, consider an end-of-day job meant to run daily. Despite there being a single end-of-day job, each run is tracked as a separate job instance, like the January 1st or January 2nd run. Even if a run fails and is rerun the next day, it retains its original identity, such as the January 1st run. So each job instance can have multiple executions, but only one job instance associated with specific job parameters at every given time. So the definition of a job instance doesn't impact data loading. That's determined by the item reader implementation. For instance, in an end-of-day scenario, the data may include a colon indicating the effective date. The January 1st run, for instance, loads data only from the 1st, and the January 2nd runs uses data from the 2nd. This decision is often a business choice for the item reader to make. However, reusing the same job instance determines whether the state, for example, the execution context from prior executions, is utilized. Starting a new job instance means being from the start, while using an existing instance generally means resume from where you left off. And then after the job instance, we have a job execution. So a job execution in Spring Batch represents a single attempt to run a job, which can result in success or failure. The associated job instance is considered incomplete until the execution successfully completes. For instance, in the context of end-of-day job, if the job instance for January 1st fails on its initial run and is rerun with the same job parameters, a new job execution is generated, but only one job instance persists. So globally, a job defines what a job is and how it is to be executed, and a job instance is a purely organizational object to group executions together, primarily to enable correct restart semantics. A job execution, however, is the primary storage mechanism of what actually happened during a run and contains many more properties that must be controlled and persisted. A step is a domain object that encapsulates an independent sequential phase of a batch job. Therefore, every job is composed entirely of one or more steps. So a step contains all the information necessary to define and control the actual batch processing. So this is necessarily vague description because the contents of any given steps are the discretion of the developer writing a job. So a step can be as simpler or as complex as the developer desires. So a simple step might load data from a file into a database requiring little or no code, depending upon the implementation used. A more complex step may have complicated business rules that are applied as part of the processing. As with a job, a step has an individual step execution that correlates with a unique job execution. So a step execution represents a single attempt to execute a step. A new step execution is created each time a step is run, similar to the job execution. However, if a step fails to execute because the step before it fails, no execution is persisted for it. A step execution is created only when each step is actually started. And step executions are represented by objects of the step execution class. Each execution contains a reference to its corresponding step and job execution and transaction related data, such as commit or rollback counts and start and end time. Additionally, each step execution contains an execution context, which contains any data a developer needs to have persisted across batch runs, such as statistics or state information needed to restart. Now let's translate all this theory to a practice. Let's go to Spring Initializer and let's create a new project. So I will select Maven as a project type or project manager, and then let's use the most recent version of Spring, which is 3.2.0, and Java language, of course. Here I'm gonna change this to com.alibu, and then as an artifact I will call it batch. So the description is a demo project for Spring Boot batch processing. All right, so here let's keep it jar and Java 17. Now let's add few dependencies. So the first thing I will need web. I want to create a simple endpoint to start or invoke my job. And then I will need Spring Batch, of course. So here when you search for batch, you have Spring Batch and it's part of the IO. And then we need, of course, PostgreSQL because we want to persist some data to our database. And then we need, of course, Lombok to reduce the boilerplate code. All right, so now our project is ready. Let's click on generate and open our project within our preferred IDE. For the sake of this tutorial, I will be using IntelliJ Ultimate version. So you can also use the community because it's totally enough for you. You don't need to have the Ultimate version. All right, so let's go ahead. So here we have our project open in our IDE. So the first thing, let's go and add some configuration. So you know my style already. So I want to use, or I prefer using YAML configuration. And the first thing that I want to configure for my project is the database connectivity. I want my application to be able to connect to a database and to persist data there. So I will provide you the configuration and I will explain them one by one. And also, if you are new with Spring Data JPA, I would like to recommend going back to my channel and checking the Spring Data JPA playlist. Alright, so this is our configuration. So we want to configure our data source, and here we have the URL, and I want to use a database called file upload. And then for the username and password, you can use username and password, or also you can change that to the corresponding one. So I will make it Alibu because my database is already configured like that. And then you need to specify the driver. Well, this one is optional, so you don't need to provide it because Spring will automatically detect the driver that we have in our pom.xml, and it will use this driver. But it is also fine to provide or to specify the driver here. So also here, this is my JPA configuration, and I want to have a DDL auto of type create drop and show SQL false. And here I want to format SQL true in case I decide to show the SQL. And now I precise the database, which is PostgreSQL. You can use a different one if you want to. And here just providing the dialect, which is PostgreSQL dialect. Alright, so now our database is configured and Spring will be able to connect to our database. Then, when starting with Spring Batch, we explained earlier that Spring Batch needs to create a schema or to create few tables in order to store and keep track of the job executions and the step executions, generally speaking. So in order to do that, we need to ask Spring Batch to what to do in order to initialize or to create the schema. So here we have several options. Whether we can ask Spring Batch to always create the schema, or we want to create our own and just tell him you can use the schema because automatically it will try to find the correct tables and use them. So here I need to provide a property called batch, and then we have another property called JDBC, and after that we have a property called initialize schema. And for this initialize schema, we have always, embedded, or never. So embedded means that it's provided, never, so do nothing with the schema, and always means that we want Spring Batch to always initialize the schema in case it does not exist. So for now, I will keep it to always as a value. And then there is one important property. So Spring Batch is enabled by default, as you can see here. So Spring Batch is automatically enabled. So execute all Spring Batch jobs in the context. And this is something that we don't want to do. We want to trigger the execution of the jobs ourselves. So let's set this one to false. Alright, next I just want to change the server port to 9090, for example. And that's it. Now our project is configured. The next step is we want to move on and prepare the connection to our database. This step you can skip it if you want to. Alright, so for people using the ultimate version, you have this option right here, database. You can click on it and then you have this plus and you can add a new data source. So let's search for PostgreSQL, and now we need to provide the configuration or the properties in order to connect to PostgreSQL. So first let's keep everything as it is because it's already installed locally on the port 5432, and now I need to provide the username and password. And then just click on test connection. So now let's apply. And in case you see this warning, so this warning like database PostgreSQL has a collation version mismatch, I will show you how to fix that. So I'm going to click OK. So in case you see that warning, so here you see that we are able to connect to our PostgreSQL. And in case you see that warning, all you need to do is to update or refresh the version. So there is a query you need to execute, which is alter collation, and then the collation name, which is PostgreSQL, and then refresh version. So if you run this command or this query right here, it will automatically update the collation version or the version that you have, and you will no longer see that warning. All right, so now let's go ahead and create a new database, and let's call it, as we mentioned in here, file upload. So file dash upload, and then let's click OK. And here I will just keep only the file upload schema, and I want to display the public one. So here we have our database ready, and our application is correctly configured, and now we are ready to start coding. So let's move on. So earlier we said that a batch processing application is composed of the following. So we have a job execution, and then it will launch or start a job, and a job is composed of one or many steps, and each step has 3 different items, which is item reader, item processor, and item writer. So now let's move on and do this, but we will do it from the bottom to the top. So this means we will start creating the items, the item reader, processor, and writer, and then configuring the step. Next, we will configure the job, and then we will start or launch our job. All right, so first thing, new class, and I will call it, or like make it in a package called config, and I will call it batch config. So in order to make this class as a configuration class, we need to add the configuration annotation, and I will also add the required args constructor from Lombok in order to inject or create my constructor for me. All right, so we said that within a step we have 3 things: reader, processor, and writer. So, and since we want to read a file and upload the data to a database, what we want to do is to create an item reader that will allow us, or will help us read data from a file. All right, so let's go ahead and do that. So for this, we will need to create a bean, and this bean, we have an object or an implementation called flat file item reader, and this we need to specify what is the object. So for now, I will keep it as an interrogation mark, and I will create the object in just a few seconds. So I will call this one item reader, for example. And for that, we need to return an item reader. But before doing that, let's go ahead and see what is this class. So always click on download source so you can see and read everything. All right, so here you see that this flat item reader already extends this class and implements this interface. And then also this one extends item stream reader, and this one extends item reader. So as you can see, this implementation is already an implementation of the item reader. And if you click here, you will see all the available implementations that you might need. So here, for example, we have Mongo paging item reader, Mongo cursor item reader, and so forth. And the one we'll be using is this flat item reader because we want to read a CSV file that we will upload to our database. All right, but before going ahead and starting implementing this item reader, here we need to specify an object. What is the type of the data that we want to read? So here we can leave it as an interrogation mark, and we need to deal with the data, the typing, casting, and so on and so forth. Or we can simply create a class and use this class as a type. So I will create here a class student, and I will move it to a package called student. So here, as you can see, I have my new package student, and inside this student, I have the student class. So let's go ahead, and for this student class, let's give it some attributes. And first, we want to have a private integer ID. So this will be also our entity that we want to persist to our database. And then we will have private string first name, and then we will have also last name, and for example a private integer or int age. All right, so these are the attributes. Now let's add some annotations. We need another getter annotation from Lombok, we need also the setter annotation, and we need the entity annotation. All right, so the entity is not available because we did not add the Spring Data JPA dependency. So let's do it manually. Now let's go to our pom.xml, and here let's add a new dependency, and here let's type spring boot starter data JPA. And now all you need to do is to refresh the project, and this dependency will be available in our class path. So now we can import the annotation entity. All right, of course, within an entity, we need to provide an ID. And this one, I wanted also to be a generated value. So now I have my student object. Let's go back and continue our batch configuration. All right, now let's create an object of type flat file item reader of type student. And then let's call it item reader equals new flat item reader. And then we need, for our item reader, we need to set the resource. So from which resource we will be reading the file. So here in this case, we will be using a new file system resource. And now we can provide the path to our file. So generally, when we talk about batch processing, maybe you will mention, or you want to mention, that you want to upload a file from your API or from your front end and then process it. So batch processing is mainly when we want to have some scheduled jobs. So for example, we have a bunch of files or a list of files, and we want to process all the data or all the items, for example, every day at midnight. All right, so what you can do is to upload the file and then place it or send it to some location. And here the file or this item reader can read the file from that specific location. So, but for the sake of this course, let's give it this path. So I want to place my file here under src main and then resources, and then I will create here a file. So let's do it now, and let's call it, for example, students or student.csv. All right, now I can copy the path of this one and paste it in here. All right, so this is the path of the file that I want to read. After that, let's give our item reader a name. So we can set a name in here, and now let's call it CSV reader, for example. All right, so after giving it a reader, so here within a CSV file, so we will have here a header. So for example, it will be ID, first name, last name, and age. And now when reading the file, we can decide how many lines we want to skip. So we can tell the item reader dot skip lines or set lines to skip. And we can say we want to skip only one line. All right, so this means we don't want to read from the header, but just from the next line. And then for this line, we need to set a mapper. So here we need to set a line mapper, and this line mapper, it will be a method that we will create in just few seconds. So here I will say line mapper as a method, and I will create it just right now. Then all I need to do now is to return my item reader. So this is the item reader, and it's ready now. Now all we need to do is to create our line mapper. All right, so for the line mapper, I will create a private method here. So it will be of type line mapper, and this line mapper will take and return a student. Okay, so let's call it line mapper. And then what we need to do, we have an object called default line mapper of type student, and let's call it line mapper equals a new default line mapper. Then we need to set our delimited line tokenizer. So it's this object here, and it's from the Org Spring Framework batch item file transform. So here let's call it line tokenizer equals new delimited line tokenizer. And this for line tokenizer. So here let's set the delimiter. So what are the delimiters of my CSV file? So my data, for example, are separated or are comma separated. So for example, let's say that my student file or my student CSV looks exactly like this. So first I will have the header, I will have ID, and then first name, and then I have last name, and then I have age. So for example, here I have the ID 1, and then I have John, and I have Doe as a last name, and let's say 25. So the delimiter we are setting is this one, how we can separate the different columns. So then I will set another property. I will tell it if it's strict or not. So it will be no. So I will set it to false. And then I want also to set my line tokenizer dot set names. So what are the names of my elements or of my different columns? So here I have the ID, and then we have our first name and then last name, as we mentioned in the CSV file exactly. So, and then finally we have age. So after that, we need another object of being wrapper field set mapper, and this one is of type student. So let's call it field set mapper equals new bean wrapper field set mapper. So I will explain what is this exactly. So this wrapper field set mapper is an object that will allow us and help us to transform each line that we will read from the CSV file to a student object. All right. So here, let's say field mapper dot set target type, and we need to provide a class. So it is our student dot class. All right. And finally, let's give our line mapper dot set line tokenizer, our line tokenizer we just implemented. And finally, we say our line mapper dot set field mapper, which is our field mapper, the object we just created. And finally, let's return our line mapper. So this is the line mapper method that will transform, or that will map, each line of our file here to a student object. So this is the main object, or the main goal of this line mapper. All right, so now we are done with the item reader. Let's move on and implement our item processor. For the item processor, I want to show you how to have your own implementation. So for that, I will create a class in here, and I will call it student processor. And this class, in order to make it an item processor, we need to implement one interface. So here I will say my student processor implements an item processor as we explained before. And as you can see here, an item processor takes an input and an output. So what is the input? So our input is of type student, and the output, for now, just for the sake of this example, it's also of type student. But in a real world project, for example, you will receive some data and you want to map it and save it to a different format or a different table. For example, receiving a list of persons containing a bunch of information, and then you want to map that one to a student, subjects, and so on and so forth. So, but for now, we just want to make it and keep it simple in order to be able to simply digest this one or this explanation. So that's why we will have the input student, and also the output will be the student itself. So here, as you can see, we have a method called process, and all the business logic goes here in order to transform your data or to process your data. So let's rename this one to a student, and here we will simply return our student object. So let's keep our student processor simple. Now let's go back to our configuration, and the same way as we defined our item reader, we want to define a bean of type item processor. So our item processor is our student processor. So student processor, and let's call it processor. And all we need to do is to return a new student processor. So that's it with the processor. Now we need to configure or to create a bean for our next element or next phase of the step, which is the writer. So the writer is the bean or the class or the implementation, you call it whatever you want, that will write the data to some system, whether it can be a database, it can be a file, it can be, for example, a bucket in the cloud, and so on and so forth. So all we need to do is to provide our processor. Okay, so in order to do that, let's first create a bean, and then let's create a bean of type public repository item writer. And then what we want to write an object of type student, which is our entity as well. So let's call it write. And then what we want to do here, we need to provide an object of type repository item writer, again of type student. I will call it writer, and then equals new repository item writer. So now I need to provide few information. So for this writer, I need to set the repository. So what is the repository? And as you can see here, it's a crude repository of type student. So for now, all I need to do is to inject private student repository, and I will call it repository, or we can also call it student repository. So for now, we don't have this repository. Let's go ahead and generate it. So I will create an interface and I will place it in the student package. Now this interface, in order to make it a JPA interface, all I need to do is to do extends JPA repository of type student, and then my ID is of type integer already. Now, if I go back here, I have my repository and I need the final keyword in order to ask Lombok to generate a constructor with this parameter. All right, so now let's go back. Let's set our repository. And then within the writer, what is the method that we want to execute? So set method name. And here we want to execute the save method of our repository. So just remember, when you have repository dot, you have also this save method. And then let's return our writer. All right, after implementing the reader, processor, and writer, now we need to define the step, because I mentioned earlier that we will start from the bottom to the top. So after preparing all these three elements, now we need to define our step. So I will create a public step. So here, as you can see, we have an interface called step, and it comes from the batch package. All right, so here I will call it, for example, import step, or you can call it or give it another name. And in order to make this one a bean, of course, we need the bean annotation. In order to create and define a step, let's do return, and then we have an object called step builder. And within this step builder, we need to provide two information. First, the step name. So let's call it CSV import. So you can give it any name you want. And then let's see the constructor in here. So let's download the source. And now you see that for this step builder, it takes a name and then a job repository. So for the job repository, we need to inject an object. And as explained before, Spring already provides us, like the Spring Batch context already provides us with an object of type job repository. So here I will create private, final, and then job repository, and I will call it job repository. So let's use this one right here. So this is my job repository. After that, we need to define few other properties. So here then we have something called chunk. So the chunk means how many records or how many lines we want to process at a time. So now let's say, for example, we want it to be 10. And also, as you can see, we need an object of type platform transaction manager. So let's go ahead and inject an object like that. So I will do private, final, and then platform transaction manager, and I will call it platform transaction manager. So here, let's provide it as a second parameter. And this chunk is a generic type. So we need to provide what are the types. So here we want student. The input and the output is also a student. All right, exactly as we did in the processor. So now within the step, we need to define the reader. What is the reader? Which is this one or this method that we implemented in here. So our reader is the item reader bean. And then we have the processor, and our processor is the processor or the bean of type processor we created before. And now we have the writer, which is our writer method or writer bean. So let's rename this one to make it writer instead of write, and then build. So in this way, we can define a step. So after the step comes the job itself. So we need now to create another bean. So bean right here, and then public. And then we have an interface called job. So this one, for example, let's call it run job. So this is the job that we want to execute. And within a job, of course, we can define multiple steps. So let's return a new job builder. So not job step builder, but just job builder. And then within this job builder, we need to give it a name. So for example, let's call it import students. And then, of course, we need again our job repository. Because if you remember from the diagram, all these steps, like the step and the job, all of them, they need to use the job repository. And then we have a method called start. So the start here, it takes two types of parameters. So whether a flow or a step. In our case, we want to execute one step. All right. So this one, we need to give it or to pass our import step bean. And then we have another method in case, for example, you want to pass the second and the third and so on and so forth, like the steps you defined. You have a next method where you can pass the second step to be executed. All right. But in our case, we have only one. And then let's just say build. So in this way, we have our job. We have all the configuration of our batch processor. Let's move on and create an endpoint in order to import or to upload our CSV file and persist it in the database. Now let's move on and create a controller, which will be our entry point in order to be able to execute this job. So I will close everything in here, and inside the student, I will create, for example, a student controller. So as I mentioned before, creating an endpoint or a controller is not mandatory because we want to have some scheduled tasks. So this is how the real world projects work. So we want to have a scheduled task that will execute automatically the job. But for the sake of this tutorial, I want to show you how to do that. So here I will just create a REST controller and I will give it a request mapping. So here I will call it simply /students, or you can do /API/students. And of course I need my required args constructor from Lombok. And now all I need to do, I need to inject an object of type JobLauncher. So this JobLauncher interface is the one that we spoke about previously. So let's call it JobLauncher. And of course, we need also the job that we want to execute. Again, I will make it private final and then job, and I will call it job. So now I will simply create a post mapping. So this because I just want to invoke or to call this endpoint. And for that one, I have here, so public void import CSV to DB, for example, and then I will call it job. So the method is called import CSV to DB job. And then what I need to do, first I need to create job parameters. So this is what we spoke about before. For a job, we need to pass some job parameters. So here I will create an object of type job parameters, and I will call it job parameters equals new job parameters builder. And then we have an add long method. So this one, we have a key and a long parameter. So we want to set when this task or when this job should start. So here, let's say start at, and then we want this job to start immediately. So let's take the system.current milliseconds. So when we call this method, or we call this endpoint, I want my job to be executed immediately. And then I have a method to job parameters that I need to call. Now, what I need to do next, I need to call my JobLauncher and then run, and I want to run a job. So I want to run my job with my job parameters. All right, so this one needs to be surrounded with try and catch, or we need to add the throws in or to the method. So let's add exceptions method to signature, or here we can select surround with try and catch. And as you can see here, it will catch many exceptions. So let's group them together. Also, we can group this one and we can group this one. So here we can just throw a new runtime exception, or we simply, for the sake of this one, just print stack trace. But in the real world, what we want to do is to log these issues. All right, so now our REST endpoint is ready. Let's move on and start testing, and also we will be improving. So this is not the end of this tutorial. We will be improving. So we will see what are the issues, what are the anomalies that we will be detecting while importing a CSV file, and mainly while importing a huge CSV file with an important number of lines. Now we are at the phase of testing what we already implemented. So for that, I asked ChatGPT, I gave it the structure, and I asked it to generate 100 students respecting first name, last name, and age, and generating some random information. So I will paste the data right here. So this is what we can see. We have these students right here. Now all I need to do is to go ahead and run the application. So let me make it full screen. And now we see that the application is up and running. And before that, I want to go to my database and refresh it and see how tables are created. So first we see here that we have 7 tables instead of 1. Even we created only one entity in our application. But if we go here, we see that we have 6 tables related to Spring Batch. So we have the batch job execution, context content, context param, instance execution, and execution context. So maybe let me open the diagram for you, and I'm gonna make it full screen. So here we see that we have the following structure, and here we have the batch job instance has job execution, and the job execution has a batch execution context and parameters, as well as batch step execution, and the batch step execution has a context. So you can have a closer look at these different tables. Now what we want to do is to run our application. So we need to invoke our endpoint, and for that I will simply go ahead and create an HTTP file that will simply make or perform a post mapping or a post call to my REST API. So here I will just right click and create an HTTP request file, and I will call it just demo. So for that, all I need to do is to do post and then localhost, and my port is 9090, and then /students. All right, so this is the endpoint we just created. Now, when I run this one, I expect to have 100 students in my table. So for now, my table is empty. And when I run this one, I expect that we import 100 students. So also I will clear the console here, so we will see the execution time of this. So now if I run it and then I go back here, we see here that the job has been executed, or the step CSV import executed in 189 milliseconds. So this is super fast. All right. So now if I again refresh my table, I see that I have the 100 student already imported in here. So let me maybe organize this one. So you see here that we have these students. All right. So next, what we want to do, we want to multiply the number of users that we already created. So I will go back here, and this one I will multiply it so many times just to have, for example, 100,000 students. All right, so here as you can see, we have 100,000 students. So you see the number of the lines right here. So we don't care about the IDs because it is already auto-generated, and it will be auto-generated by Spring. So let me restart the application, because we need to restart the application in order to load the new content of the file. So the application is up and running. Let me clean this, and let me also double check that the student is empty. All right. So now if I run again this endpoint, let's see what will happen. So first you see that it's still spinning. So it's running, and this is gonna take some time. Maybe seconds, maybe minutes, depending on the machine where you are running this import. But let's wait and see how long it will take to import 100,000 students. So here it's done. And if I go back and check the output, so it took 20 seconds to import 100,000 students. And now if I check again, we see here that we have so many students. All right. So here we see that we only have 100 students because we are reading the ID from the CSV file, and Hibernate will automatically update. So let's do some changes and retest again. So now we can do it in 2 different ways. So whether we can remove the ID column from the CSV file, which will be a long thing to do, but the easiest step is to go to the student processor. And what I want to do here, I want to say student.setID, and I will set the ID to null. So because when we pass a null ID value, Hibernate will automatically persist or create a new entry in our database. So in this way, you see here that even we are processing or we are doing some logic in here. So I will restart the application and then let's try to import again. So let me clean this one. Also, let's make sure that the list of student is empty again. And now let's run the endpoint and wait for around 20 seconds to finish processing all this data. And then I will absolutely show you how to improve the performance of your Spring Batch processing, because we need to reduce this 20 seconds, because imagine importing a file or uploading a file containing millions of records. So 20 seconds for 100,000 is not acceptable. All right, so it's about to be done. And even I can show the log right here. Once it's done, it will log the execution time. So now maybe it will take more than 20 seconds. Also, as you can see, since we have a longer process and we have something different and we are persisting always, so it's not just an update, it's a creation or insertion into the database. So the execution is taking a bit longer. So we need to improve that absolutely. So here, as you can see, every time I refresh the data, we see that we have new data is getting persisted. And here, so for example, it's 91,000. And if I move on and refresh again, so it's still persisting the data. So it's taking some time. And we need absolutely to improve that. And there are so many ways of improvements in order to improve the processing. Alright, so importing 100,000 students, like simple data, nothing is complicated, took 6 minutes 35 seconds. So now let's see how we can improve that. So now in order to improve the import and the batch processing, what we can do in our batch configuration, and for this step, we can define something or an object called Task Executor. So Task Executor will help us and allow us to define how many parallel threads we want to execute for our step. So first, let's define a bean of type Task Executor. So here I will type public and then Task Executor, and I will call it Task Executor. And then what I will be using, so I will use an object of type simple async task executor, and I will call it async task executor, new async task executor. After that, what we can say, so async task executor set concurrency limit. So how many threads we want to run. And then let's return our async task executor, and let's understand what is this. So if we go to the official documentation, so this sets the maximum number of parallel task executions allowed. So the default is -1, indicates no concurrency limit at all. So when we imported our CSV file the first time, it was using only one task. And just to make sure, here the value of this concurrent limit, as you can see here, it's set to unbounded concurrency, and this one equals already -1. So we have no parallel threads running. And now, after defining this task executor, so here on the step level, we can define task executor and we can pass our task executor bean. Also, something important, you need to be careful about this. You need also to take care about the resources and the power of your machine where you are executing this batch processing. So now let's restart again our application and let's run the import again. So the application is up and running, and now I will open my demo file or my HTTP file, and I will just run this one again. So let's see how much this will improve the import and how long it will take. Alright, so the file has been totally processed. Now let's check how long this one took. Alright, so here we see that it took 36 seconds instead of 6 minutes 35 seconds. So you see now the difference by just implementing or by just allowing or having 10 threads running. You can increase this one to 30, for example, or a different number and check the difference. Now I want also to show you some other way of improving, and this also might improve a little bit our processing. So let me make this one full screen. And as you can see here, we have this chunk. So the chunk, we have 10 records per thread. We can, for example, improve, or like we can make this one 1000 and rerun the application again and see. But first, let's double check that we have all the 100,000 students in our database. As you can see here, we have all of them. So now by also increasing the chunk size, let's restart the application and see if this is gonna also improve the batch processing of our file. So here the application is up and running, and I will again start importing and see how long this is gonna take. All right, so the import is done. Now let's go and check how long it took. So now we see now it took only 29 seconds. So we also improved it by 6 seconds. And believe me, 6 seconds in a production or in a highly scalable application and on a high demand application, this really counts. All right, so we saw how we can improve our batch processing. Also, we can improve it using partitions, and this is something we will see next.